Okay, now that we have talked about how to solve quadratic equations, we're going to move on to lesson 4.6 in your BJU Press Algebra 2 textbook, which is about solving quadratic inequalities. So because we already know how to solve quadratic equations, solving quadratic inequalities is going to be so similar. We're going to use the same methods to solve quadratic inequalities, but you had to have the following 3 steps in order to do it. So the first step you're going to have to do is you're going to have to complete the square. So remember how I said completing the square when you are solving quadratic equations is sometimes a little tedious and it's not always the best method to use. But when you're going to solve quadratic inequalities, you're going to have to complete the square. So it's going to be very important for you to know how to complete the square because you have to use it in order to solve quadratic inequalities. So that's step 1. And then once you have completed once you have completed step 1, which is completing the square, step 2 is going to be taking the square root of both sides. Because once you have completed the square, you have created a perfect square. And once you have the perfect square, you can take the square root of both sides. And then once you've done that, step 3 is going to be using or applying the compound inequality theorem. Which goes back to section 2.8. All right, so you have to use the absolute values. That's using the compound inequality theorem. So because of that, all of our other shortcuts that we've learned can't be used. You have to use these steps in order when you're doing quadratic inequalities. So let's go back to 2.8 real quick and take a look at that compound inequality theorem. Because it might have been a while since you have looked at that. So let me remind you what it is, okay? So first of all, on the compound inequality theorem, we need to note that n has to be a positive real number in all of these cases. Has to be positive real number, okay? So if n is a positive real number, then this is how the compound inequality theorem works. So if you have an absolute value that is less than n, then that means x is greater than negative n and x is less than n. So that can also be rewritten as negative n is less than x, which is less than positive n. Okay? Now, if your absolute value of x is greater than n, then you get, because this was a conjunction, because it had the and, but if it's greater than n, then you get a disjunction, and that says that either x is less than negative n, or x is greater than n. So again, this is something that we covered a while back, so you might want to rewrite this down, okay, and have it handy because we're going to need it every time we solve a quadratic inequality. So now that we reviewed that, let's go ahead and look at example 1. So I'm going to go ahead and keep this handy as we look at example 1, which says solve x squared plus 2x minus 5 is greater than 0. Okay? So step 1, remember, is complete the square. So we need to complete the square. So in order to complete the square, we first have to move the constant to the other side. So I'm going to go ahead and move this minus 5 to the other side. So I'm going to add 5 to both sides. So then I get x squared plus 2x minus 5. Oh, not minus 5 anymore. Oh. Okay, so x squared plus 2x is greater than 5. Okay, now that I've done that, I can go ahead and complete the square. So I'm going to take, remember completing the square is taking half of b and then squaring it and then adding that to both sides. So my b value is 2, so I'm going to take half of 2, and then I'm going to square it. So half of 2 is 1, and then 1 squared is 1. So that's what I'm going to add to both sides. I'm adding 1 to both sides. So that means I get x squared plus 2x plus 1 is greater than 5 plus 1 is 6. Okay? So now that I've completed the square, I can rewrite this as a perfect square. So remember, we guaranteed that this is a perfect square, so we can just take the square root of the first term and the last term and then keep our operation. So the square root of x squared is x. This is a addition, and then the square root of 1 is 1. All right, so now I'm done completing the square. So step 3 is, step 2 is take the square roots of both sides, right? Take the square root of both sides. So the square root of this, and then the square root of that. So the square root of x plus 1 squared just becomes x plus 1. And so remember, because we're doing an inequality, that becomes the absolute value of x plus 1. And then the square root of 6 is a decimal. Don't want a decimal, just leave it as the square root of 6. It doesn't simplify, so just leave it as the square root of 6. And then now that I've done that, I have to, step 3, use the compound inequality theorem. So I had to decide, is n a positive real number? Is the square root of 6 a positive real number? Yes, it's positive, it's real, it's not imaginary. So we're good there. So is our absolute value less than or greater than n? It's greater than. So that means that we have a disjunction, which means that we're going to follow this formula, okay, which says x is less than negative n or x is greater than n. So we're going to say x, which is what's in the absolute value symbol, so x plus 1, okay, that's our x, is less than negative n. So we're going to say x plus 1 is less than negative, and then our n is the square root of 6. Okay, or, because remember we're doing the disjunction, x, which is x plus 1, that's what's inside our absolute value symbol, is greater than n. So x plus 1 is greater than n, which was the absolute value of 6. I'm sorry, the square root of 6. All right, so now that I'm here, I just need to simplify. I need to solve for x, right? So let's solve for x. We're going to start with subtracting 1. Okay, so then I get x is less than negative 1 minus the square root of 6. Or, if I subtract 1 here, I get x is greater than negative 1 plus the square root of 6. All right, and that's it. That can't be simplified any further. So I'm done there. So notice how I did not do a decimal. I just left it as the square root of 6. Please don't do decimals, okay? Just leave them as simplified radicals. All right, let's try another example. So again, keep this handy. This is going to be key in solving inequalities, quadratic inequalities. We're going to solve 4x squared minus 32x minus 3 is less than or equal to 0. Okay, so we need to complete the square. So first thing we need to do is move the constant over. So we're going to add 3 to both sides. So then we get 4x squared minus 32x is less than or equal to 3. Okay, in order to complete the square, we have to get rid of that a term, which is a 4. So we need to factor out that a term. So when I factor it out, I end up with 4 times x squared minus 8x is less than or equal to 3. Okay, because 4 times x squared is 4x squared. 4 times negative 8 is negative 32x. All right, so I've taken care of my a term. So now what I would like to do, I'm going to go ahead and move that a term over so that way it's not in my way anymore. So I'll divide both sides by 4. So now I have x squared minus 8x is less than or equal to 3 over 4. And that makes it a little bit easier to finish completing the square. So my b value is 8. So to complete the square, I need to take half of 8 and then square it and then add it to both sides. So half of 8 is 4, and then 4 squared is 16. So that's what I'm going to add to both sides. I'm going to add 16 to both sides. So I'm adding 16, adding 16. So now I have x squared minus 8x plus 16 is less than or equal to 3/4 plus 16. You can rewrite 16 as 64 over 4 and then add 3/4 to it. You end up with 67 over 4. Okay? I've guaranteed that this is a perfect square now by completing the square. So I'll take the square root of the first term, which is x, bring down the operation, which is subtraction. The square root of 16 is 4. So there we go. And then we have 67 over 4. All right, so I have completed the square. Step 2, take the square root of both sides. All right, so the square root of x minus 4 squared becomes the absolute value of x minus 4. And then the square root of 67 over the square root of 4, that's the same as saying the square root of 67 over the square root of 4. I can rewrite it like that. The square root of 67 is a decimal, so I'm just going to leave it as the square root of 67. And the square root of 4 is 2, so I'm going to go ahead and change that to 2. All right, then, now that I have taken the square root of both sides, step 3, use the compound inequality theorem from section 2.8. So first check, is your n a positive real number? Is the square root of 67 over 2 a positive real number? Yes, it's positive and it's not imaginary. So then, is your absolute value less than or greater than your n? We are looking at something that is less than. So because it's less than, we are going to be dealing with a conjunction, or and, right? Which says that either whatever is inside your absolute value symbol is greater than the opposite of n, and whatever is inside your absolute value symbol is less than n. So we'll write that. I'm actually going to go ahead and write it as 1. So I'm going to do opposite of n, less than what's inside my absolute value symbol, which is less than n. Okay? Except for, remember, we're using less than or equal to. We have less than or equal to. So again, you start with the opposite of n. So the opposite of the square root of 67 over 2 is negative. Square root of 67 over 2 is that less than or equal to x minus 4, which is what's inside our absolute value symbol, which is less than or equal to just n, which was the square root of 67 over 2. All right, so very last step, I'm going to get rid of that 4. So I need to add 4 to both sides. Since I have a 3-part inequality, I'm actually going to add 4 to all 3 sides, because if I add it here, I have to add it here, and I have to add it here, okay? When I add 4, because I have a fraction, I'm going to go ahead and rewrite 4, because remember 4 is the same as saying 8 over 2, and if I rewrite as 8 over 2, then I can go ahead and combine these. And then I get 8 minus the square root of 67 over 2 is less than or equal to x, which is less than or equal to, remember I rewrite 4 as 8 over 2, so I get 8 plus the square root of 67 over 2. So I just rewrote it as one fraction. Okay, and that's how you solve quadratic inequalities. Go ahead and try some problems on your own.